So now in the last video I did a step-by-step build of this circuit. It is pretty simple, and the main thing to be aware of is that the transistor has the base left floating. We didn't connect anything to the base, the middle pin of the 2N2222, and the emitter is towards the positive side of the power supply while the collector is towards the negative side of the power supply. That is backwards from what you normally would wire it up as. But in any case, if you didn't see that video, there is the schematic right there. We will get the multimeter here. Might as well zoom in now, and we will look at the purpose of this just really quick. It is to give a pulse, or probably better, a series of pulses, or probably better to call it a strobe. So right now the bench supply is on, but at 0 volts, and for some reason, there we go, it didn't want to hold in place. So there, I'm raising the voltage. You're going to see at pretty much spot on 9 volts the LED starts strobing. So let's see if I can actually get it down to 9. Yep, 9 actually works, but we'll go a little bit higher. You get the voltage faster, and it goes even faster right there. So it's a 1 kilo ohm resistor. I do not want to go above 12 volts. So in any case, let us turn the power off, and I'll turn the voltage down to nothing. So in any case, we're going to make a couple of modifications. So a commenter mentioned that they had, first off, 120 ohm resistor between the LED and the collector. And so let's see if I can yank that out. Fortunately, I had to obscure the vision. So we're going to put the resistor down there, and the LED, of course, it's polarized. Long lead, the anode, has to go towards the positive side of the power supply. Short lead, the cathode, towards the negative. So we go there. And I have a 120 ohm resistor right here. We will go from there to there. And so they did not, for whatever reason, they didn't specify, they didn't change the voltage with the power supply. They wanted to change it with the trimpot, and that caused problems. So we are going to remove this resistor right there and put the capacitor back. So make sure it's polarized, so make sure that side's towards the more negative side, and then the positive side is to the emitter at the top there. So down below I have a trimpot right there, and so we will just take the jumper here at the output, and we may not be able to see it too well, but I'm going to put that to where the emitter is. Right there. So we replace the resistor going from the power supply to the emitter with a trimpot here. And it is set kind of high. We should set that lower. So now I added a resistor up here because we have the potential of going all the way to the positive rail. My power supply only goes to 18 volts, but that will be a direct 18 volts with no resistance in it going to the emitter of the transistor. And as we already saw, the way the transistor is, that can conduct probably fully, and so we don't want that. It'd be better to put the resistor right here and kind of shift the voltage of the voltage divider, but for now we'll just be careful. We'll set this all the way down to negative. We'll come here and zoom in. That looks not too bad right there. So let's turn the power supply back on, and the voltage up to 18 volts. But again, the trimpot is set to nothing, to 0 volts I should say. And I'm going to need that screwdriver a little bit, so I better not put it anywhere too far. So there you can see 18.55 volts at the rail. That's as high as my power supply will go. And we go to the trimpot here, and for me, I did do this test earlier. It seemed to, when I got to about 8.5 volts or so, it started flashing. Yeah, I think even with the resistor. There we go. And you can see it rapidly flashed all of a sudden. I go a little lower in voltage, it stops. Now it's going really fast, and now it's probably really flashing super fast that it looks on, but any case, there you can see that's the effect we got. And so now it's steadily on. I don't want to go any more positive. I can go a bit more positive, but any case, we might hit the rail. So that is with the resistor there, and so that's not terrible. They said they had to go up to 13 volts. I don't have that problem. Maybe it's because they're using a different type of transistor than I am, the 2N2222. So if you're using a substitute transistor, you may have to use all of your NPN substitute transistors till you find one with the same basic properties. So we will now, so it worked for me, it didn't work for them, and it didn't really quite work as well as directly to supply, in my opinion, but if you're perfectly happy with that, that's fine too. Again, I recommend the resistor there though, and so we can pop that out, and all that's gonna do, pop out this jumper here, is make it so we always have at least 2,000 ohms to the positive rail. And so when we put the trimpot halfway, it's going to be closer than halfway to the negative rail. So the voltage is going to be slightly lower. So the power supply is still 18 volts. This meter starts beeping after a while if you haven't done anything. So let's look at the voltage. I thought I turned the power supply off, but I didn't. It was still on. And now we will turn this up. And you can see we got to get, looks like a little bit closer to over there, but you can see it's flashing, so that works fine. And I can go all the way to the positive rail, and it looks like we broke a point where it started alternating again. Now you're going to notice that the voltage is holding steady at that point. That is because the transistor is letting current go through once a voltage hits a certain point, and so we can't get a voltage build up there. It drops, the capacitor starts discharging a bit, and then it will stop conducting and kind of hold that voltage there. And this pulse is just when it is discharging that capacitor quickly. So the capacitor, we're not going to get a higher voltage. If we remove the jumper there, now you will see that we can get higher than 9 volts right here. And so it doesn't give you an accurate display of what we are getting. Well, that is flashing. So there we go, 13. That is with the resistor. Again, you don't want to go out the way to the rail without a resistor. So I highly recommend the resistor. Now, let us remove the 150 ohm resistor and just look at the trimpot. So for me it worked. For them, the combination of the two did not work, but the combination of the two did work for me. And again, it's good to test out these things. That is actually how you learn. You don't quite, that missed the spot I wanted to go. You don't really learn electronics terribly well if you just build a schematic and you're happy that the circuit works. It's experimenting with it and figuring out how you can manipulate it yourself when you really start learning electronics pretty well. So I'm gonna move this. Let's put it over here again and put the capacitor there. So the jumper from the trimpot. There we go. So the power supply is set, voltage is set down, and so now, or no, it's up to 18 volts. And so we don't have anything going on right now. Let's look at the voltage at the trimpot here. So yeah, looks like 7 volts. Let's turn her up. And there you can see it flashing. And as I turn the trimpot more there, now we see that it's slowed down a little bit. No, it looks like it's back up. So there we go. Again, if we didn't have this resistor, so they didn't mention having this resistor. This is a 5,000 ohm trimpot though. They said they used a 5,000 ohm. trimpot, and so I grabbed the same value. Now we'll go here, and that should make a difference, the value of the trimpot, because a higher value trimpot, even though you get the same voltage, it will let less current go through. And then a lower value trimpot, it's going to let more current go through, even if you set it to the same position, trying to get the same voltage, because it has less impedance even though you set it to a voltage. So there we go, 8.7. And again, we have to be careful we don't turn it all the way to the rail. There you can see it going faster, and that's probably, we got 18 volts at the rail. That's probably kind of pushing it. And maybe there's 2 kilo ohms of resistance, I don't know. I don't want to go less than 2 kilo ohms of resistance with 18 volts. So we're going to taper it down. That's why I used a 2 kilo ohm resistor there. I can turn it there, and then I know I still got 2 kilo ohms of resistance. So, because the transistor and the LED really aren't limiting much current, we really want to depend on that. So I don't like this jumper directly there. I suggest the resistor. But in any case, hopefully you found all that interesting. As I said before, that's good that somebody tried to make a difference. So why would they want a resistor before the LED? Maybe to limit current a little bit more. And it's really odd where you have power just going right through an LED, and so the capacitor charge up, discharges through the capacitor and the LED pretty much instantly. That's why it's a pulse, and or a strobe, however you want to look at it. And so maybe you think you got to have some resistance there, but the capacitor, it's a 1000 microfarad, doesn't store a ton of energy, and the transistor provides a little bit of resistance and whatnot, so it shouldn't be a problem. Maybe it is pulsing a little more current than it should, but as we could see, it didn't seem to work as well, in my opinion, with the resistor, but it did work with the resistor, at least with my setup. Now with the trimpot, maybe you have whatever, an 18-20 volt power supply or something, 24 volt batteries, who knows, and you want to get a fraction of that, and a trimpot's an easy way. But as I said before, you got to make sure you have enough resistance towards the positive rail, because negative, the circuit is ending at the negative rail. So negative to negative, there's no voltage difference, no current, you don't have to worry about anything heating up. But you get all the way to the positive rail, now you have a almost direct connection from positive rail to negative. You're going to get high current flow, and that could hopefully fry the LED, but maybe fry the transistor. Both of them aren't terribly expensive though, so not end of the world if you fry one of them. But the likeliness goes way up, and it's good to just always practice good behavior. So I recommend, if you're going to do something like this, keep the 2000, it's actually a 2200 kilo ohm resistor. I think that's the one. These resistors, so I'm going to ramble a little more. Hopefully you're enjoying it. These resistors are, they were cheap, and so one thing I noticed, a commenter for the product on Amazon said the leads are thin, so I point that out. They do seem a bit more thin, and also the color code is not, okay, that was my 120 ohm resistor. That's what that was. That was the one that was over here. So yeah, it was brown. It does look pretty brown, but I thought maybe the red on here is not very red. I don't know if we'll be able to get in there. So sometimes it's a little hard to tell if it's brown or red because of the color. So let's get the loop out. And so these, as I said before, their leads seem pretty thin, and also the coloring of the stripes don't seem that good. I gotta move the lamp. There we go. So yeah, you can tell they're red there. There's brown, but when the light's not on, I'm very good. They kind of look brown right there. So also some of them, the paint didn't really cover it very well. You gotta kind of look at the other side. Sometimes there's a stripe like missing on one side. But they were cheap, and I got a wide range of values. So for me, they worked out good. But in any case, I recommend, if you're going to use a trimpot like this, anytime you use the trimpot. If you don't have current being limited at the output there, use a resistor. So it's going to shift where the halfway point is. It's going to make the halfway point a little more over here, because instead of 5,000 ohms, now we have 7,000 ohms. So we can't get all the way up to 18 volts. It looked like it was up to 13. And so we can't get all the way, but we still have resistance there no matter what. And so that is one safety measure. So I'm going to stop rambling there now, and don't be afraid to experiment, but as I said before, always eliminate the chance of too much current. And that's why you learn Ohm's law, and also the I don't think there's a real term for it, but power law, or the Ohm's law formula for power, where you got the voltage times the current for the wattage. So make sure your components can handle the wattage that you demand of them. These are quarter watt, and so even 2,200 ohms of resistance with 18 volts across it, I think is over 1/8 of a watt. If it's rated for a quarter watt, you still want to keep it about 1/8 of a watt. You can go a little bit higher or whatever. The hotter components get, though, the shorter their life gets, so you really don't want to push it too much. But any case, experiment away, and that's actually how you learn. You can easily build a circuit from a schematic and not learn anything. You just connect the where they tell you to connect, and it does what you know it's going to do anyways. They already told you what it's going to do. What you want to do is learn the electrical properties and try to make changes to it to the best of your ability, and test out theories that you have. So I've thought stuff would work out. I tried it. It didn't work out. I figured out what was wrong with my thinking before. So luckily these days I have more free time where I can test things out right away instead of thinking them up at work, getting all excited, getting home, finding out it didn't work. But any case, it's still fun to not get it right at first, but you figure out how do I do it. So that's enough rambling. Thanks for watching. I'll see you in the next video.